Hello everyone and welcome to the CP-31 Sheet Solutions. Today we'll be discussing the 1600 rated problem, advertising agency. So let's pull up the CP-31 sheet and let's open up the problem. And yeah, so the problem goes, Marsha works in an advertising agency. In order to promote the new brand, she wants to conclude contracts with some bloggers. So she has some collection of bloggers, etc., etc. Essentially, she has K bloggers which she can contract with, and she wants to choose the maximum followers amongst the bloggers she's choosing, right? So that's what she wants. And uh all the bloggers followers are different, right? Basically they're not overlapping. And she wants to choose K bloggers such that they have maximum sum of followers. Okay. And we have to find the number of ways to choose these K followers so that we get a maximum sum. Since the answer can be quite large, output it mod 10 power 9 plus 7. And then can go up to 1000 and there are 1000 test cases. Okay. So let's have a look at the problem. So uh time expected is obviously n squared, right? Since n in k is going up to 1000. Okay. Although there's no okay, there is a guarantee. Okay, so n squared. All right. Okay, so to start off, let's simplify the problem. So simplify the problem, and what we'll do is we'll basically say that given a bunch of numbers, right? Like 1, 1, 2, 2, 3, 4, 5, 6, 6, 6, 7. We need to choose k of these numbers, right? Some k, it can be any k. So let's say k equals 5 numbers. So 1, 2, 3, 4, 5. We need to choose the 5 numbers that give us a maximum sum. Okay. So k numbers that give us a maximum sum, right? That's basically we need to find number of ways, right? Number of ways mod 10 power 9 plus 7. So this is a relatively very easy question for 1600 rated, I would say, right? So basically observe this given example over here. If we have to choose 5 numbers to give us maximum sum, obviously it would be the largest 5 numbers, correct? It would be the largest 5 numbers. So here we have only one way. We have no choice but to pick these 5 numbers, right? So we have only one way here. We have only one way here. Okay. So what if let's try a array which gives us more than one way? Um, so what we can see is basically, let's say our array was entirely ones, right? And we have to choose 5 again. So here we can choose any 5, right? Choose any 5 since the sum will remain the same maximum sum, and we can choose any 5 we want, right? So our answer would be simply n choose k, correct? So how do we figure out a formula for this? Well, it's actually pretty simple. So yeah, let's take the k highest blogger. So let k equals 4 for example, right? So we know that we need to pick these 4 because they're the highest number of followers they have, and this 3, right? But these two bloggers also have 3 followers, so we can choose any two out of these, right? We can choose any two out of these. Or basically, what is happening is this the blogger which is on the boundary, right? That we have chosen some of the bloggers with frequency 3 and not the other bloggers with frequency 3. Those bloggers are the important ones, right? Those bloggers are the important ones. Or basically, when sorted in reverse order, so when sorted in in descending order, right? Uh, let's say we write this in descending order. So 4, 4, 3, 3, 3, 3, 2, 2, 1, 1, k equals 4. So we choose the top 4 bloggers, right? We choose 1, 2, and here we need to choose in these 4 we need to choose any two, right? Choose any two, right? So our answer will be 4 choose 2. Okay. Basically, we can choose any two and it will still give us the same sum, right? We want the maximum sum and all of these are equal numbers. So yeah, so once we have sorted in descending order, the element at position, element at position A of k, okay, at position A of k, um, or technically if you say zero index, it would be A of k minus 1. So element at position A of k minus 1. So that will be this element. What frequency does it have? Right, the frequency is equal to 4 and the number of this element which are less than equal to k, right? So there are two occurrences, so we need to choose two of these, right? Choose two and frequency till position less than equal to position frequency till position less than k, right? Less than k is equal to 2. So basically our answer is simply 4 choose 2, or in other words it is the frequency of position A of k minus 1 choose frequency for I less than k of position A of k minus 1, right? Because that is the only one in which we can make a choice. In all the larger elements, which we have to take anyways, we have to take all of them. And these we definitely do not have to take. Only the one which is at the boundary, we can choose to take some other three as well, right? Some other person who has 3 followers, some other influencer with 3 followers. So yeah, that's about it for this question. Um, to compute to compute n choose k, we can use the standard formula, right? N choose k equals uh, n times n minus 1 times n minus 2, right? Like this, 1 times 2 times 3 times 4 times k, right? This is the formula for n choose k. So we can calculate this mod 10 power 9 plus 7 using modular inverse, right? So you can go read up on modular inverse. We can just use modular inverse to calculate this. An alternate way is to use Pascal's triangle, but that is more complicated. It's much simpler to just use modular inverse. You can use a template. For example, you can go through my code. I have a simple template for modular addition, subtraction, multiplication, exponentiation, as well as inverse, right? So you can also make your own functions for all of these and you can just use them, right? So we need to know how to do modular inverse or modular division, right? To be able to calculate this 10 power 9 plus 7. This can be calculated as simply big O of k, right? The loop will be big O of k times the time taken to calculate modular inverse, which is log n, right? Log n. Or k can go up to n. So we can write the time complexity as roughly big O of n log n, right? So we have done much better than the n squared. We can just directly solve this question in big O of n log n. And the memory complexity remains O of n itself, right? So big O of n log n. With Pascal's triangle, you can do it in big O of n squared. That's why I think they've given n squared constraints. But we don't need to care about Pascal's triangle. I think it's much simpler to just use modular inverse method, right? So that's it. The question was pretty simple, I think. Even basic combinatorics suffices. Just need to realize that the element at the boundary matters. We can choose the amount needed for that element from the total frequency of that element, right? So let's have a look at the code now. Here's the code. Um, so here is just the template for mod operations. You can go through it once. Okay. So we take in our n and k, we take in our array A, we sort it in reverse order, in descending order. Now we need to do n choose R for A equals k minus 1, right? We need to find how many frequency it has. So I'm just counting how much frequency it has, total, as well as the frequency less than k, right? So if I less than k, what is the frequency? This is our capital N, this is our capital R. Now I just need capital N choose capital R. So using its direct formula, n factorial divided by n factorial minus R factorial times R factorial. Or if you write in expanded form, if you write it in the expanded form, it's going to be this, right? This is the formula for n choose k. So that's all. We set our initial value as 1. We can multiply it with n minus I plus 1 and divide it by I, right? So that's how we are multiplying by each term one by one. multiplying by this, then this, then this, dividing by this, then this, and doing it using inverse modulo function, right? This is division, by the way. A value multiplied by the inverse of some number is equal to this value divided by this number with the given mod. The mod is set here, as you can observe. The mod is already defined in these functions. Okay, and then finally we can output the mod. So that's about it for this question. Pretty straightforward in my opinion. If you didn't get it, definitely do practice combinatorics more. It was a pretty basic combinatorics question. All right, thank you for watching and see you in the next solution. Bye bye.